In this section, we're going to talk about microscopy. So what we're talking about is using a microscope, viewing specimens, and then being able to do some calculations with that. In microbiology, in a regular lab, we're working with a compound microscope. The total magnification, as high as you can get, the maximum level is going to be 1,000 times. I don't care what the brand is, that's as high as it's going to go. Now you can go to higher magnification if you use things like an electron microscope, but for a compound microscope, 1,000 is magnification is as high as you can go. There are a few terms to be familiar with when working with a microscope. The working distance, sometimes you'll hear people talk about that. The working distance, that's the distance between the specimen slide and the objective lens. As you increase the magnification, the objective lenses get longer. You're going to be getting closer and closer to the specimen, which means that working distance is going to decrease as you increase the magnification. The field of view, that's the area that you see when you're looking actually through the microscope. It's a circle, you're looking through it, that's your field of view. Your field of view is also going to decrease as you increase the magnification. Parafocal and resolution are two additional terms that you often hear associated with microscopy. Parafocal, this just means that when you change from one objective lens to another, the specimen should still be seen. If you have it in the center of your field of view, when you switch that objective lens, you should still see something there. Now, it may not be completely in focus, but at least you could see a shadow. Usually you can still see most of the object, but you may have to focus it. Resolution just means that when you're looking through the microscope and you see two items, you see them as two distinct items. Sometimes as you increase magnification, you're going to notice when two things are right close to each other. Do you see them as two separate items or not? That's what we're referring to with resolution. Now this is just an example of a compound microscope. Up here, which is commonly referred to as the eyepiece or the eye lens, we refer to it as the ocular lens. I don't know if you can tell here, there's one back here and one here because you're looking at an angle at this one microscope. This is a binocular, so you've got two ocular lenses. Usually when you have a binocular one, and this is true for this one, you can slide the two ocular lenses left and right to fit your face. This is down here, the nose piece, and these are the objective lenses. These are the ones that you will switch to increase the magnification. So if you start on the lowest or the shortest objective lens, and then you slowly rotate from one to another. This is your mechanical stage. This it's kind of hard to see on here, but there's clips usually here that will hold your slide that has your specimen on it in place. For this particular microscope, there's some knobs down here. They're a little bit hard to see, but they will move. There's two sets of knobs. They will move the sample on the slide. It's going to move that slide left to right or front to back so you can position it correctly. Down here below the mechanical stage, this is the base and this is the arm. This is your light source. So the light is going to come up from the bottom. Pass through here, you've got both your condenser as well as an iris. An iris is kind of like the shutter on a camera where you can adjust the amount of light coming in. On this particular microscope, this knob right here, this is my on-off switch, and it also is a dimmer, so you can increase or decrease the light intensity coming up through your sample. These knobs back here, on the back right here, the larger knob is the coarse adjustment, and the inner smaller knob is your fine adjustment. So typically what I recommend when you have a sample on your slide, you put the slide on the stage here. I recommend to bring the stage all the way up as high as it can go, and then slowly move it down while you're looking through the ocular lens, and use your coarse adjustment. Once you see it, then you use the fine adjustment knob to get it all nicely fine-tuned and clear focus. Then you just rotate. Like I said, this is a revolving nose piece. You're just going to rotate to the next objective lens. Do not be moving the stage up and down. Don't make things harder than it needs to be. What you're going to do is, that's where we're talking about parfocal, that you leave the state, you find the sample at the lowest objective, get it nicely in focus. Don't move the stage, leave it where it's at. Just switch, rotate this around to switch to the next objective lens. From that point on, you're going to be fairly close, because remember that working distance between the objective lens and where the specimen slide is, that's going to start decreasing as you increase the objective lens, increase that magnification. And so use just your fine focus, because you're starting to get pretty close to the slide. You should still see it, just use that fine focus to get it nice, clearly focused. Switch to the next objective lens. So what are some of the measurements you can do? Number one, you can determine the total magnification of the sample that you're looking at. How do you do this? Just simply multiply the ocular lens magnification by the objective lens magnification. That gives you the total magnification. You can determine the field diameter. Now, usually what you have to do is on one of the objective lenses, typically the shortest one, which on most microscopes is going to be 4x objective lens, you actually take a ruler and you measure the distance across the diameter. So you're looking through the microscope and you actually measure what is that distance. So you get that measurement for A, you know the objective lens. Now if you want to know the field diameter at the next objective lens B, you know which one that is, the magnification of that. And then, so magnification of objective lens A, you know that. Field diameter of A, you know that because you just measured it. Multiply those two, divide by the objective lens magnification of the one that you're trying to determine the field diameter for. And why do you want to know what the field diameter? This is the distance across that field of view. You need to know that number to determine the cell size. So you take the field diameter, you divide that by the number of cells, not that you see, but the number of cells that you would estimate lined up end to end to fit across the diameter. And that will tell you the cell size of an individual, whatever it is you're looking at. Maybe a bacteria, maybe a fungus. So there's a huge range in the sizes of cells, so this will give you some clue as to that.